So we will go to our model, and then we will check what are those members. Oh, sorry, get the wrong file. Okay, so we have so you can select only, you can select the section only. So we need to know this, we need to know this. So you go to display, and then go to plane, and then I will consider XY volume. I will consider only at the gap, at the gap, because I don't need to see the upper section. I don't want to put loadings in that section. I want to consider XY volume. I will select the bottom one. Okay, select the bottom one, and then the upper one. So that's 8 and 7.5 apply. So it will look like this now. XY volume, select the joint. Select this joint. You go to display. Go to plane. And then XY volume. XY volume. And then select the joint. This joint. Bottom joint. Select the upper boundary. Okay. So I have now this side. Then I will display. I want to show the joint. So go to display, go to labeling, and then the name of the joint. Check, name. Check the name. So this is now S1 301, S4 381L, S5 281L, S2 201L, S3 101L, and E6 181L. Okay. So we have already identified this gap, So we have first here, the second here. So we will make a load case, Deflection here, loss of support here, loss of support here. So we have 1, 2, 3, 4, 5, and 6. 6, 1 support at a time. So you make this smaller, minimize this, and go to gap jacket. But we have to model first, the load combination, I mean. So you can go here, go to SACS, your SACS file, and then go to data file, data file. Go to data file. Okay, so we have LC select. It should be in gap. We will make a combination now, So go down, scroll down, and go to load combination. So this is our load combination, Take note, each support. So in each support, there will be a separate load combination. So for example, if support 1, loss of support, so you have 1 load combination. Okay. So this is GRB1 or GRB. We will change this one to GRB1, meaning to say support 1, GRB2 support 2, GRB3 support 3, GRB4 support 4. Now it will be much easier, So I will double click this one. I will change the GRB to GRB1. So this means loss of support 1. Now make backspace. It should be backspace, So GRB1 represent load at loss of support 1. So press OK. GRB2 represent the loss of support 2. So GRB2. Okay? I will copy this one. Put the cursor here. Put the cursor here at the top. And then press Control, and then scroll down. So that's how to copy. Okay, scroll down, right click, right click, copy. So put the cursor here at the end, and then right click again, and then paste. Okay, so I have already now GRB1212. We will change this one. We will represent loss of support on 3. So I will make this GRB3. Loss of support 4, I will make this GRB4. And so on and so forth. So if you have 8 possible combination, you have 8 combination GRB up to GRB8, right? So just copy and then change 1, 2, 3, 4. Okay. Since we have 4 combinations, I will copy again this one. I will put my cursor here and then press Control and then scroll down. So it will look like that. Okay. Right click, copy, or you can press Control key or C, Copy, and then put the cursor here, and then paste. So I will change this one, 5, 6, 7, and then 8. Okay? So I have now 8. 1, 2, 3, 4, 5, 6, 7, 8. Usually, when you make combination, you should know what is that combination. Like, for example, GRB1. I know GRB1, loss of support 1. GRB2. I know GRB2, that loss of support 2. Right? Okay. We have now the load combination here. We will update the load select. Load select from 1, 2, 3, 4, 5, 6, 7, 8. Okay. I will move up. Move up, up. Go up. Okay, go up. And then in the load select, you should change this to GRB1, 2, GRB3, GRB4, GRB5, GRB6, GRB7, GRB8. Okay, so 8 only. 9 is unstable. So if you insist, you put 9 load case, you got problem in instability. So it will be error in your part. Okay, so LC gap now is complete. Okay, so this is no COG shift. Now that's the first case. We will update now the gap input. Gap input. So I will close this one. Okay, of course, save the file first. Close this one and go to the gap input file. Go to the gap input file. So open it in the datagen file. Okay, we will update this one. LC gap. So GRB1 is loss of support 1. So I will update this one. It becomes 1 and then what member? So you remember for S1, so support 1, this is support 1, right? This is loss of support 1. So it should be S1 and 301L. This is loss 1. S1 and 301L. Are you following? S1 and 301L. Okay. Save. Now once you master this one, you no need to open like that. You can just update and type now. So like for example, like here, 2. So I'll just go 2 and then scroll and scroll and scroll, and then I know already that this is what? See? At the bottom, you notice at the bottom that's the first member start join. So for 2, it should be S2 and what? So you go here, it should be S2 and 201L, right? 201L, S2, 201L. So I will update this, S2 and then 201L, just right. Or If you don't like that one, so you can go like this. Much better. It's accurate. Nah? Okay? So press OK now. I will copy this one. Same procedure. No? Same procedure. Put the cursor here. Press Control and then scroll down. I will copy. I will make another load combination. Copy. Put the cursor here. Right click and then paste. This becomes what? 3. GRB3 represent S3. Right? Oh, S3. Right. No, it's 3. And then I will consider S3. This is S3. Support. Close of support at S3. So member is S3 and 101L. S3 and 101L. Okay? So S3 101L. Right? S4. Okay, I will update this. I will put 4. Very simple. And then no load on that member on GRB4. So for GRB4, it is S4, right? S4 381L. S4 381L. S4 381L. 381L. Okay. So we need another load combination. Okay, so copy, same procedure. It's only repetition. Control and scroll down. Right click, copy or Control C. And then right click again, paste. So I change this to what? 5, 6, 7, 8. We have 8 combinations, right? Yes. Okay. But take note, you have to change the member. So case 5, GRB5. For case 5, or loss of support at 5, we have here, no support here. So I have S5 and 281L. S5, 281L. So S5, 281L. S5, 281L. Now if you have a file which is different from my file, you have to update based on your file, of course. Do not follow my file. So it depends on the name. In this case, this is 281 in my file. Okay? Or you can rename it. So like for example, S1. So it's automatic inside my mind, it's duet 1, right? So that's the naming convention is very important. Like for example, when you have top side model and you have jacket model, when you merge it, what will happen if you have two the same joint? Error. So the best thing to do, jacket 1,000, 2,000, 3,000, 4,000. Top side 8,000, 9,000, something like that. So that's the very basic in joint convention. Because when you merge it, you got no problem. Okay, next. GRB6. GRB6. So loss of support 6. So this is not to simulate this one. I have S6 181L. E6 181L. 181L. Okay. 7 case. So this is now the case where two supports are not active. So it's impossible for this and this to have negative or downward reaction because you have the center of gravity here. So that's possible. So loss of support S1 301L and S4 381L. So you have two case, 6. Sorry, 7. 7 is 2, no? So I have 7 S1 and 301L. You have 2, 301L and S4 at the same time 381L. No? You have two, huh? See? You have two loss of support. One here and the other here. Two supports at the same time. Okay? Case 7. So, it's okay now, huh? Press OK. And don't forget to save the file. GRB8. GRB8. The 8 loss of support at S2 and S5 simultaneously. So, you have support, loss of support here, no? Okay? So, I will simulate that one at 8. GRB8. So, in between, I have S2. I have 201L. And then S5. Hope you follow. And then I have 281L. Two support at the same time. Two loss of support at the same time. Press OK. Save the file. And then you can run now the analysis. Take note. We don't apply yet the winch, pull, and friction. So you have to compute for the pulling force of the winch. You have to compute for the friction. Okay? So, run the analysis to get the reaction. We will run the analysis. Okay? Close this one. We will perform gap run analysis. Do not consider it joint can check because it's not complete. The loading are not complete yet. So just run the analysis. Run wizard. Be sure it is in gap element. Gap element. Otherwise, the compression supports only will not be activated. Start wizard. Select the SACS file. Select the SACS file. And then select the model. This is the model, right? Press open. And then gap input. So I have gap input jacket. Gap input. Open. And then be sure you got the post view. Post data. So check this. Select this. And then check create post view database. Post view database. Okay? So no need join check will not be performed yet because the loadings are not complete. Press OK. Perform the analysis. If there are some error, you can check. Okay, in my case, no error. Okay. Now, I will compute friction and winch pull. So, how to compute? We need the reaction first. Go to post view. Okay, so this is now the post view, right? We will check first if the program is correct or the result is correct by visual. We will unselect first the riser and the riser stub. So press select. Display settings, exclude. Go to exclude and then put here RST. That's the riser stub. And then riser RSR. Press OK. So this is now, it will look like this. The risers are excluded. Okay. Go to display. Go to shape. To view. Maximum displacement. And then check animation of shape. And then increase this to 200. Press OK. The first one is GRB1. See? It deflects here, right? That's the first. It deflects here. That's what we want, right? The first case is support displacement or no support at this side, S1. Second, I will go to load. Display next load case. See? The second. This is support 2, right? Support 2. Load, support 3. See, in here it supports. Now you notice the deflection is less than 100. See, this is the deflection. So it's okay. No? It's okay. You will not be angry with the T&I contractor because the deflection is not more than. So you have to check. No? Okay. Load. I will deflect this. No load here. Display next load case. So here. So usually, it will be critical when the support is removed on the hardest point. Hard point, usually the joints, joints of the jacket. Go to load, display load case. So this one, see, it deflects on the side. So you can visually check. It deflects here, so bending is big here. Punching also on this side. Load, this case, support 6, S6, Next will be this. We want to deflect here at the same time. So go to load, display load case, see? Whoops. So it deflects here. Maximum deflection is only 9 mm, so it's okay. Okay, go to load. So it deflects at the same time on this direction, see, in the support, So you notice the support activated is here, 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 and here. 4 supports. So if you check this one, go to display. Go to display and press select. And then check color code UC. You remember the UC color code UC ranges, we have 0.8 to 1, it fails. So it will be like this. It's already failed. The red one fails. Now for this case, GRB8, this one and this one fails. During lifting, this one fails also. So you really need to change this in the actual. Okay. We still have one forces. We still have one forces. Friction and the pull of the winch. So we will go to load. Report. Go to report. This is very important because this loadout is not complete without friction. So go to report. This is how to determine reaction. Reaction. Go to joints and go to report. Go to joints. We need to consider what is the reaction here. So go to report. Go to joints and then reaction. Okay, I will put GRB1 load. Okay, and then I will select all. All joints. All joints. But my load will be table. I will select GRB1. So I want only reaction at GRB1 on all joints. Okay? GRB1 load, go to table, your joint should be all, your load should be GRB1. Okay? Your load should be GRB1. Press OK. So these are now the loadings. Now you don't need this 101L, 181. This is actually reaction on the springs, right? You don't need this one. What you need is this. You need S1, S2, S3, S4, S5, S6. I will copy this one. Drag downward. And then copy. Right click, copy. Okay? Follow? Yes. Okay? So right click, copy. And then go to the Excel file. If you have this one, go to that and then make a copy right here. Go to the COG shifting in lifting. You can use the COG. Okay? So I will copy the file here. Okay, I will put the file here in sheet 3. And then I will right click. Right click, paste. Do not change like that, Do not alter, Do not alter this one. Just only right click and then paste. And then go to data. And then text to column. So the file can be converted into usable Excel. So go to text column. Okay. Go next. Press next. You have to check if it's on this line, line. Otherwise, if it's not on the line, you can update and then click finish. Okay. So this is now my reaction. These are my reactions. See, it's usable now. You can use now. You can use now the Excel. Okay, I will arrange this. I will delete this file, this row. No, delete. Yes. I will delete this file. We don't need this one, right? That's the reaction on the springs. Okay. So what I need is this one. What I need is the FZ, right? I need reaction. Now, based on the design basis, what is the coefficient of friction? Coefficient of static friction is 0.15. No? We will use 0.15. So I will write here coefficient of friction. My coefficient of friction 0.15. No? 0.15. We will use 0.15. Okay? The static of friction is 0.15. Okay, try to save this. We will compute frictional forces. What is friction? What is the formula? Friction. Friction is equal to coefficient of friction. Of course, we will use the static. Do not use dynamic. Dynamic is already moving. Static is more bigger compared to dynamic. So we will use static. Coefficient times what? Times reaction or normal force. Right? Mechanics. Mechanics 101. Friction force is coefficient of friction multiplied by the reaction or normal force. So I will compute the friction here. So I will put here Fk, meaning friction kinetic. So I will compute equal to mu, coefficient of friction, multiplied by normal force, which is this. But I will make this automatic with the coefficient of friction. So I will put $sign in between. Enter. So I will make decrease. I will decrease this one. Okay. So almost equivalent to 0, and then drag. This is basic Excel now. So these are my friction forces. These are my friction forces. S1, S2, S3, S4, S5, S6, GRB1. Okay. I'm going to ask you now, what will be the force on the winch? I will apply now. I will find force on winch. Force on winch, I will calculate the force rho A and the force required on rho B. Right? So what is the force required on rho B? What is the force required on rho A? You have to check with this. See, this is the very principle. When you apply a winch force here, your force should overcome the frictional resistance, or it should be equal, to start moving or impending moving. So our winch force on A is what? what is the Wind force you are going to apply on A? It should be the friction on this plus the friction on this plus the friction on this. Is that correct? I will apply a force here, like for example, this one. To calculate the wind's pull, I need to overcome the friction here, plus here, plus here. So when you pull, that's the winding force. Now that's the minimum. So try to notice this in row A, right? This is row A. You are going to add the friction in what? S3 plus S2 plus S1. And on row B, this is row B, right? I will add friction from S6 plus S5 plus S4. Okay. So, go back to the Excel. Wind force on A is how much? Equal, what is the force on A? Row A. Again, it should be this 1, 3, 2, and 1. No? 3, 2, and 1. So it should be S1, S2, and S3. That's for row A, kilonewtons. And on row B is 4, S5, S6. So that's the force. We will apply this now to our model. You follow the principle. It's only principle. Once you know the principle, I don't need SACS. So this is the principle. Due to that combination, you calculate the reaction, you multiply it by coefficient friction, that's the friction. You add the friction on that side, that's the winding force on that side. You add the winding force, the friction on this side, that's the winding force on that side, right? So the add, submission, same as weight, So I will apply, on row A, 24824, and this one. Okay. I will close this. And then I will go to my file. Go to model. We will apply now the winding force. We will apply now the friction. So in order for you to have a good look, go to display. Go to plane, and then go to XY volume. Select this. Select the joint or the plane you want to display, and then display plane XY volume. Select, apply. So it will look like that. First, I will apply friction. So, I will go to load, joints. You apply friction here at the bottom. You apply friction at the support, at the bottom. This is the bottom. So, I will make this bigger. Apply it here. The friction should be applied here. At the bottom. Bottom. Okay? I will apply friction. Okay? Go to load. Go to joints. The load is in joints. So go to load. Go to joints. I will select this. That's S3. S3. Apply. I will put this one as PN1 load. Meaning to say GRB1. Again, I have 1 as GRB1. Load condition, so I will call this as pull and friction. P-U-L-N-F-R-I-C. So you will understand that's pull plus friction. P-N-1, pull and prick. Okay? And you'll notice our movement is from here to left. Nah? It moves in this direction, see? It moves in that direction, right? So this is now the load out direction towards left. So if our direction or our load direction is to the left, what is the direction of your friction? Always opposite to the direction of motion. So if your motion to the left, your friction to the right. So it should be to the right, no? Fx, x to the right. So it is plus. What is S3? Friction S3 is how much? To the right, that's plus. S3 is 94.21. S3, right? 94.21 to the right. 94.21 to the right. Plus. Because your movement is to the left, your friction to the right. Opposite. To the right, To the right, 94.21, 94.21. Okay. So press save. This one. S2. S2, Apply. So go to S2, select S2, apply. Pull and friction. Press add. And what is S2? The first S2 is 154.03. Na? 154.03. So this is combination of Excel. 154.03. 1 plus active, no? 154.03. Okay? Press OK. And then save. S1. S1 is actually 0, no? Because the loss of support on gravity 1 is this. But we will still put a value. Because we will copy this one. We will use this one. Add. And then, what is first S1? That's 0. I'll just put 0. Just put 0. Press OK. Save again. On the side, that's S4. Na? S4. Apply. S4. Select the joint. Apply. Add. And then S4, how much? 52.62. 52.62. 52.62. Press OK. So you are now here. Save. And select another joint. S5. Apply. Follow? S5. Press add. And then go to your Excel. S5 is 120.55. 120.55. 120.55. Press OK. Save. And then the S6. Press apply. Add load. S6 is 69.16. 69.16. 69.16. Okay? 69.16. Okay. Save. What else? You apply friction. You apply also the winching force. You can apply it in here, in between this. I'll make this bigger. Okay. I will apply it in between of this member, this gap. Or you can apply it in here. It's a small difference. You can apply it in joint or in here. I will apply it in between to simulate the eccentricity. So I will go to load. It's no longer joint load but member. Now, in here. Now, in this member. Now, in this member, this gap. Apply still PN1 and put it concentrated. Concentrated, Pull and friction still the same. Concentrated. Add. And then you go to global X. Global X, And then what is the value? This is, what row is this? Row A. No, this is row A, right? That's row A. So, what is the winching force on row A? Winch force on row A is 248.24. 248.24. So, I will apply to the left. So, minus 248.24. What is the distance in between the length? So, this is actually, the length is 0.5, The length of the gap, we introduced 0.5, so it should be 0.25. One half of the length. Okay, so it should be like this. It will look like that. Okay, save. Follow? Yes. On this side also, apply the force. Here, the winching force. Apply. Concentrated. Add global X. And what is the force on row B? Row B is 242.33. 242.33. 242.33. 242.33. Press OK. And then save. And then save your model. Okay. So that's the principle. Take note, what load is that? PN1 under GRB1. So if you have GRB2, another PN2. If you have GRB3, PN3 up to 8, PN8. So we will combine gravity plus displacement plus PN. So you go to load. You follow the sequence. So loss of support plus gravity load plus the winching force. Because that's the reality. When you pull, possible it will deflect, right? And there are friction. Okay. So go to load. Go to combined load conditions. Take note, this is PN1, right? So PN1 should be under GRB1. So I will scroll here. I will change only GRB1. GRB1. Press OK. And then I will edit. Meaning to say, I will just only update. Okay. 100 GCK plus what? PN1. No? Or you go here. You select PN1 here. And then add. Oops. Okay. I will add PN1. Add. Factor of 1 only. I will update GRB1. Okay. Press OK. Close. That's it for GRB1. If you have PN2, friction 2, that's you add it in GRB2. If I will update only GRB1 here, no need to update in the gap input. So I will run now the analysis. We will run now the analysis with gravity, with loss of support, plus the winching force. Take note, GRB1, we apply friction and winch force. So I will perform now analysis now. Okay? So do not leave like that. So it should be like this. Or you can go. You have already run the analysis. So just double click this. So it's automatic now. Double click the run. You have already performed the run analysis run file. Double click this one. It will go automatic like this. Okay, I will run the analysis. Just double click the run file. No need to go run file wizard and then. So you have to go like this. Double click that one and then so like this, run. Okay. Then we will check what happened when you put a lateral load. Display, shape, maximum displacement, then press animation, press OK. What happened? Will look like that. Huh? But it's not, it will not like this. Now that's why, see, you notice we apply. Now, this is one thing, huh? You notice in here, this is spring. Huh? That's why in some analysis, some engineers will not put this as spring. They put it 11000 only without any spring because but still it's okay. No? Or you will increase the stiffness. You will increase the stiffness of this. We apply only 100, right? In this, you can apply 1000. No, 1000. Okay. So say, I will go to display. I will unselect the riser and riser stub. It's not good to look, no? Okay, and then I will go to display. Shape, maximum displacement, check animation shape, and press OK. So it will look like that. Because there's a pull here, there's a pull here, and there's a friction. Huh? The rest, it's only deflection because there is no pull. Nah? It's only deflection. So if you want to add, you go here. Nah? In this case, same as what we did in GRB1. I will go to report. I will go to joints. I will go to reaction. And then again, GRB2. Huh? GRB2 now. And then I will go to load. I will select GRB2. Okay? GRB2. I want the reaction on load GRB2. Take note, GRB1 and GRB2 are not the same. Because GRB1 loss of support on support 1. GRB2 is loss of support in support 2. So the reactions are not the same, even though the combinations are the same, right? You follow? Even though combination for GRB1 and GRB2 is the same, dead weight and miscellaneous load, but the reactions are not equal because the reaction support, no? GRB2. Press OK. Okay, I have now. As what I did in GRB2 and 1, I mean, I will copy this one, right click, copy, and then put it in my Excel file. Same. What else? Assuming you have already the pulling force, what is lacking in this analysis? The COG shift. What else? Usually load out, no wind loads, huh? Because you will not perform load out when the weather condition is not okay. Huh? Have you seen any contractor, installation contractor who will perform load out when the wind is above a certain limit? No. So that's the procedure. Huh? That's the procedure. Okay? So you have to add, na? We have already this one. So you go right click, you go paste, do not change, then go to data, and then text column. Na? Text column. Text column, just press next, next, finish. This is now GRB2. I don't need the reaction 101, 1OL, so delete it. That's GRB2. Support 1, support 2, and then I will copy this. So I have already now the value. Oh. I have to delete this. Well, anyway, don't worry, because I will send the file with complete COG. Complete already. So the gap input file, the model file. So how to apply the COG? So if you have the COG sheet, just like this. Now I have the COG sheet. For example, this one. I will simulate only shift 1, this one. Minus x plus y. So you have to apply 13.5, 126, 126, 13.5. You notice these loadings are the same as lifting. So you copy across the lifting COG shift and then apply. Done. Or if you don't want, you apply this one as load. So you apply. Okay, go to load. This is the principle only, Go to load. Joins. Apply a COG shift. So here, 219L. What is 219L in shift 1? 13.5, minus 13.5. COG1. So COG1 is minus X plus COG1. We will check this one. Minus X plus Y. Minus X plus Y. Okay? And then G minus 13.5. Right? Minus 13.5. So this is now COG. Please save. Downward here, directly opposite to that is plus. Now that's the principle, because it's coupled. So if this is downward, directly here is plus. Save. Select here. Apply. Add. Since the other side is minus, it should be plus. This side, Okay. Save. On this side also. This joint is 299L. So based on our calculation, 299L is 126.3. Downward forces should be minus. 126.3 is upward. Upward, 126.3. Okay? 126.3. Pre-save. This is upward. Directly, diagonal, diagonal to that is minus. Save. In here, yes. Minus. Save. Save. Okay. Now, you don't need to add the COG shift in the original case without COG shift. The first is without COG shift, right? The first combination we have is without COG shift. The second will be with COG shift. So you will make another load combination. Usually, if a load combination, I will add combination in the data file because I can check it. I can check it. So I will save this one and then close. I will go to data generator. In the data gen. Click and drag. Go to data file. Go down. Go down. So the first, you can put, this is PN1. The second will be PN2 if you have PN2. The third will be PN3, PN4, PN5 up to PN8. Na? Up to PN8. So go to here. Now I will make another combination. Okay, I will put. So that's why. So it's like this. It's always an error if you put blank. Huh? You should not go like this. Huh? Always check. It should not be like that. If you want if you want to write something, you put first asterisk. Okay, I will put this as COG shift 1. Meaning to say, this is my combination for the first COG shift. Enter. I will copy this one. I will copy this one. Control. I will copy this. Okay. Scroll down. Right click. Copy. Right click. Paste. Okay. But do not leave a space. So cut that one. Okay. But you notice, this is the same right here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right? So I will put this one. This is first shift 1. So I will just make this 11, 12, 13, GR14, GR15, GR16, GR17, GR18. Which means the first shift is 11, 12, 13. The second shift is GR21, 22. So I have for shift 1, 1. For shift 2, 22, GR23, 24, 25. And what is lacking here? The COG shift. So I will apply COG1 with a factor of 1.0. In here also, I will add COG1 in here. So I will put COG1 1.0. Take note, this is lacking because supposedly GRB2 has PN2, GRB3 has PN3, GRB4 has PN4, GRB8 has PN8. Okay? So this is for example only. So what is lacking here is 2. This is how to simulate or how to apply the COG shift. So for this, COG1 with a factor of 1.0. COG2 with a factor of 1.0. Oh, why it's 2? 1. COG1 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 COG1. Take note, this one PN1, PN2, PN3, PN4 up to PN8. This one also has PN1, PN2, PN3, PN8. Okay? Now, after the COG shift 1, we still have COG shift 2. You apply COG shift 2. Well, anyway, I will send to you the file. Now, I will send to you the file with this. Okay, with the PN1, PN2. Okay? So, after this one, we update the load. GR11, 12, 13, 14, 15, 16, 17, 18. So, move up, go up, add GR11, 12, up to 18. So, in here, right click, just copy this one and update, right? Right click, copy, put the file here, paste, And this becomes 11, 12, 13, 14, 15, 16, 17, 18. Okay? Now, I have updated here. You should update also the gap input. 11, 12, 13, 14, 15, 16, 17, 18. Right? So, close this file. You have already? 11, update 11 up to 18. So, it's very clear that 11, 12, 13, 14 is shift 1. And GRB1, GRB2 is no shift. I will go to gap input file, of course, on the data file. Now it's just the same, right? These combination are the same. Shift 1, loss of support 1. Shift 1, loss of support 2. Shift 1, loss of support 3. Shift 1, loss of support 4. So I will just copy this one. Control. Right click. Copy. And then right click again. Paste. You put a space and then put a asterisk. And then you put an indication so that the checker will not be confused. COG shift 1. COG shift 1. But take note, you have the same combination. And what is the combination when there is shifting? Update this one to 11, 12, 13, 14, 15, 16, 17, up to 18. You follow?
Yes.
If you have shift 2, this becomes 21, 22, 23. So, how to make it simple for you to check the combination. Okay, we will perform now the analysis. So, once you have completed all, no COG shift, COG1, COG2, COG3, COG4, PN1, PN2, PN3, PN4, you can perform now the join can and the can collapse. Can collapse will be performed using spreadsheets. Okay, we will perform now the analysis. Run. And check if there are some errors. In this case, no errors found. Go to post view. Okay, we will go directly to the COG shift. The COG shift case. This is GRB1. So go to load. Go to load. In order to go directly to GR11, go to load, display load case, and select here. We need only GR11 up to 18. Okay. Apply. Oops. That's GR11. And go to load next. So that's GR12. GR12. COG shift 12. Oop. Loss of support 3. But there is no friction here. No friction because we didn't compute the friction. Okay, maybe I'll go around to check. Fine. Yeah. Yeah, because there is an error. So I go to this. Go to find error. Find error. Okay, enter. That element is 2 to 1 not found. It's 2 to 1 not found. So in your gap input, that element to 1. Oh, that is 2 to 1 not found. This 1 3 1. Not the 1.
Hết.
I like this one.
Rồi, xếp.
Still there's an error. You have to check your gap. I think the problem with that is your gap number. Not the same. So on Monday, because tomorrow no training, right?
Yes.
Yeah. I think they will use this conference room.
Yes.
Yeah. So on Monday and Tuesday, you have to model this one. No? This quiz. No? This is the quiz. So you will perform lifting, of course, modeling, lifting, and loadout. Because this one is useless. This is useless if there will be no hands-on. It's actually hands-on, and you will know. No? So on Monday I will send the file with complete shifting plus the pull, no, the winch pull. One thing also, during load out, if the buoyancy tank is there, you have to add the loads. Huh? Because sometimes, like for example, in this case, the reserve buoyancy, now that's the ratio between the weight of the jacket in air to the buoyancy. So like for example, there is a condition, 15% for intact and damaged condition 10%. Because once the jacket is in water and your buoyancy is not enough, what will happen? It will go down. So you have to add buoyancy tanks. So you have to put buoyancy tanks and what else? The rigging platform. You have to put the rigging platform. So it depends on the procedure, is installation procedure. So you have to check, you have to look at the procedure. If during load out, these loadings are there, you have to add, you have to update. Okay? So the assignment, where is it? I have actually made already that one. This one. This is located on 79.5 meter. Actually, in the actual, there are too many loadings. In the top side. Equipment loading and those electricals, cables. It will not be applied as joint load but bulk load. It's bulk load. So you have to check the weight control report. You have to check the layout of the equipment. You have to check the live loads, the open area live loads. So many. This one is very simple. That's why you have to master first the modeling. That's very important. Your SACS analysis will not work when your model is wrong. That's a problem. So you have to model it correctly. Okay?
Okay.
So on Monday, maybe Tuesday, exam. But exam not unlike in school. Well, once you fail, you'll be scolded by your teacher. But in here, no. I will go around, and then you got a problem, then it will be hands-on. Bit like that. Okay, if you haven't signed the attendance, you have signed. Is there any question? This one. Oh, Miss.
Có mail.
Em gửi rồi mà. Em gửi hôm nay rồi đấy ạ. Có email của anh.
Đâu?
Đấy đây.
Riêng đâu?
Anh này có tên anh đấy, anh check lại đi.
Có anh Văn anh ơi. Em riêng em gửi anh ạ.
Ai mà chưa nhận được thì em gửi tiếp, nhưng mà anh Văn anh là có rồi.
Đúng rồi.
Em hỏi qua. 11 trang đi anh ạ.
I mean the executive loadout file, the load file.
No, we didn't get the loadout file.
Today you check us about the speeding the technique.
Yes, actually that's the from lifting. We model it. I haven't sent the loadout file. I haven't sent.
Ai mà chưa nhận
I
được
can
thì
stop the program.
khi nào có